This is Mr. Wright. Today we are going to look at another transformation. This time we're going to look at reflections. So reflections occur when you flip over an axis of symmetry. So two of the ones that we're going to start off with within the coordinate plane are the x-axis and the y-axis. So when we're reflecting over an axis, so if I'm reflecting over the x-axis, this is my x-axis. When you flip over that, the point is always gonna be the same distance away from that line that you're flipping over. So for example, if this is the point that I'm flipping over the x-axis, this point is 2 spaces away from the line of reflection. So on the other side of the line of reflection, the new point is gonna be 2 spaces away, 1, 2. So that's how we came up with that new point. This point is 3 spaces away from the line of reflection. 1, 2, 3. So on the other side of the line of reflection, it's always going to be perpendicular. It's going to be 1, 2, 3 spaces away. Then the last point is 1, 2, 3, 4, 5, 6, 7, 8 spaces away from the line of reflection. So to figure out where that new point goes, you just go 8 spaces in the opposite direction. 1, 2, 3, 4, 5, 6, 7, 8. So on a graph, that's how you can figure out a line of reflection. So if you notice these dots, like these points connecting the two lines, are always perpendicular to the line of reflection. So you always move in a perpendicular manner to the line of reflection. So you always stay like on that same line. So now for reflecting across the y-axis, so I'm going to move perpendicular to that line. So I'm going to go left and right because that would be perpendicular to the y-axis. And we just count the number of spaces. So this first point is 1, 2, 3 spaces to the left of the y-axis. So I'm going to go 3 spaces to the right. 1, 2, 3. So that's where that point would move. This point is 2 spaces away. So I'm going to go 2 spaces to the right. This point is 9 spaces to the left of the y-axis. So I'm going to go 9 spaces to the right of the y-axis. So it's always that same distance on that line. And then this point is 8 spaces to the left. So I'm going to go 8 spaces to the right. So line of reflection, like the points are always the same distance apart. All right, so that's how you would do a line of reflection on a graph. Let's look at, so there's 4 that we're going to focus on. So this is like the notation we use for reflections. So the big R stands for reflections. So we're going to reflect across the y-axis, the x-axis, the line y equals x, and the line y equals negative x. Each of these has a special rule. The xy rule for when you're reflecting across the y-axis is the opposite of x, then y. The rule for when you're reflecting across the x-axis is x, then the opposite of y. The rule when you're reflecting across y equals x is y, then x. And then across y equals negative x is the opposite of y, and then the opposite of x. Okay, so the way that we apply these rules, if I'm reflecting those 3 points across the y-axis, that means that each of my x coordinates are going to become the opposite sign. Okay, so because that was a positive 7, so I'm just going to do all my x coordinates at the same time. So instead of a positive 7, it's going to become negative 7. Instead of a negative 1, it becomes positive 1. Instead of a positive 3, it becomes negative 3. And then the y coordinate just stays the same. So 5 just stays 5. Negative 4 just stays negative 4. And negative 6 stays negative 6. So that's what that means. As the x becomes the opposite sign, the y coordinate stays the same. When we flip across the x-axis, the x coordinate just stays the same. So my x coordinates would be, they just stay 7, negative 1, 3. So they all stay the same. then the y coordinate now becomes the opposite sign. So instead of positive 5, it becomes negative 5. Instead of negative 4, it becomes positive 4. Instead of negative 6, it becomes positive 6. So negative become positive, positive become negative. It just becomes the opposite. When I'm reflecting across this line, y equals x, what we do is you switch the x and the y coordinate. So we just write the y coordinate first, and then we write the x coordinate. So my y coordinates, and they all stay the same. They stay the same sign. So my y coordinates are just 5, negative 4, and negative 6. And then we just write the x coordinate second, and it stays the same sign. 7, negative 1, 3. All right, and then the last one, now we kind of switch and flip around everything. So first we write the opposite of the y coordinate. So my y coordinate, instead of 5, I'm going to write negative 5. Instead of negative 4, I'm going to write positive 4. Instead of negative 6, I'm going to write positive 6. So I did the opposite of all the y coordinates. Then I do the opposite of each of the x coordinates. So instead of 7, I'm going to write negative 7. Instead of negative 1, I'm going to write positive 1. Instead of 3, I'm going to write negative 3. So that's how you read these rules, is these negatives in front of like the letters, that just means opposite. So it changes to the opposite sign. And then if like the x and the y are mixed up, that just means you switch them around. Another thing you're going to have to do is like look at the ordered pairs to figure out like what transformation took place. So remember, like every time you're given an ordered pair, it's always starts out as xy. And then you want to think what switched around. Did anything change signs? Did they switch places? So what I notice with this, with just looking at k, is the 5 was the y, now it's now the first letter. So the y went there, and then the x went there. So the only thing that happened was they switched spots. They didn't change signs, they stayed the same signs, and they just switched spots. So if that's my xy rule, I go back and look which one has that xy rule. It would be a reflection across y equals x. So that is the transformation that took place, is a reflection across y equals x. Okay, so this one, if I just pick a point to focus on, this will be another example. If this is the point I'm going to focus on, remember the original point is just xy. And then how does it change? So I noticed that they write the y first and it became the opposite sign. And then they wrote the x coordinate and it became the opposite sign. So that's my xy rule. And I know that that rule matches up with the reflection across the line y equals negative x. So that's what transformation took place, was a reflection across y equals negative x. That is how reflections work.